warn you, I make some really corny, dumb, lame, groaner analogies and sometimes math jokes during the semester. And it's okay to groan. That's an approved activity. Now, we have just 3 minutes left till we're going to start. I do believe in starting on time. Hint, hint. Now, okay, we will meet the 3 times a week. We have a very burdensome schedule. They have merged 011 and 012. For those of you who took 011 last semester, if there are any of you in here who did, and I'm not going to ask you to show your hands, but if they did, bummer for you, because you're going to get a lot more repeat material than you would have otherwise. Okay, now the net effect of this is we're going to really have to push to get all the material covered each week, because every Sunday night you have homework due in ALEKS. I'll talk about ALEKS more. ALEKS is a smart mathematical homework program, meaning you get stuff wrong, it gives you more problems to practice on and more tutorial, and your homework gets much longer. Grab one of each and start filling out the information while I'm up here blabbering around. Okay. Sometimes I don't take myself real serious. Anyway, the first thing you're going to do when you get signed into ALEKS, and as I said, we're going to deal with that some more, is you're going to take something called a knowledge test or a knowledge check. Okay, if you were in 011, you know what I'm talking about. Or if you've previously taken 012, you know what I'm talking about. Okay. Grab handouts, start filling out the information sheet while I'm talking, and then we'll keep going. The knowledge check is incredibly important. You're going to have one first thing you do, then you're probably going to have at least 4 more during the semester. Now, here is why those are important to you. If you find them boring and just click, don't know, don't know, don't know, don't know, you are going to have horrendous homework assignments. Okay? If you get careless a lot, make an abundance of errors, you will have more homework than the person who gets more correct. So the more you get correct, is the less homework you have. Is that a plus? Yeah, I think so. Okay, so that's my story about knowledge checks. Oh, I've got a student that's signed in. Recordings and stuff. No, let's don't deal with that. Okay, let's don't do it. But I've kind of given you the parameters on phones. Any questions so far? Okay. First thing you're going to need to do in this course is you're going to need to register into ALEKS. You must do that through Blackboard. So this is just a page in Blackboard where you see here is a video on how to link into ALEKS. Here is a YouTube where you find the videos that are in the ebook of ALEKS. You have an ebook available. Now, I would recommend that you get a hard copy. You can buy a manuscript copy, meaning loose leaf, out from within ALEKS. But I don't know about this class, but the college algebra one went up from less than 100 to 192. So I just don't know what to expect. There is a used bookstore, except this is a brand new book, this ebook resource. You also have a number of videos and supplemental materials that you can access. Here's our class. Okay. Whoops, that one is my college algebra. I mean my online one. Okay, you do that and it takes you to the announcement page. How many of you have already been to this page? Good, good, good on you. There's a number of things in here that are kind of important, okay, and useful to you. The first one right here, uploading a PDF, okay? This video link tells you how, if you don't have a printer scanner, that you can take an image with your phone of a document or multiple documents, merge them into a single PDF, and then email it. Okay? Guess what your first assignment is? To do that. The very last page of your packet is the same thing that you just filled out to give me tonight. What you're going to do is you're going to go home, you're going to refill this out using either a printer scanner or this technique that it shows you, or whatever method that you have available. Scan that completed page in, and then you are going to email it to me at pymanjc@aol.com. Okay, that is the email that I prefer to use for all correspondence. I check it multiple times a day. My WSU one, james.carter@wichita.edu, I check about once a day or every other day. Okay, so this is the one you want to use. Now, on this file that you're going to send me, there's a certain file process or pattern that I would like for you to use on any PDFs, photographs, whatever that you send to me during the course. And that format is, the first thing I want you to do is I want you to write M012-F22. So far it's pretty, oh, guess what? I left something out. Last, first, dash, last name, first name, no spaces. No spaces. Dash, M012, dash, F22 for fall 22. And in this case, info sheet. And then PDF. Okay. This part of this thing, this much, should be the same on any file you send me. Oh, but this one is going to change depending on what it is. This one's a descriptor one. So does that file structure make sense to you? Okay, for doing the PDF things. Okay, which brings us to what we're going to cover. So let's get started. I already told most of you, some of you might not have been here, we have a real tight deadline week to week. Every Sunday night, you have homework. Alex says it's at 11:59. But a couple of years, it's been East Coast time, which means 10:59 our time. So just be aware, I can't check it out yet until the homework service, till the end of this week. And then I can check it if it's not correct. Also, I've got a brand new pointer this year. I've had one that had nice big white buttons on it, and I have a clumsy thumb. And this one is kind of little, but for the sake of the video, I had to have a pointer that was a little not red, and my old one was red. And this pointer shows up, the old pointer didn't. So, oh well. I may hit the wrong button from time to time. Okay, here's what we're going to be covering initially. And here is your second assignment. You're thinking, oh no. This one's actually pretty easy. This is one of the very first, it's one of the pages in your packet. See if you can find it. What? It should have a number at the bottom of the page. Page 1? Okay. Or 1A or something like that. Okay, this is a clue word list. Now, I've already told you that 012 this year is a merger of 011 and 012 from previous years. Okay, so we're going to be covering some material that maybe or maybe not everybody in here needs. But if even one needs it, then it's important. Okay, the clue words, math has its own language. Everything has a certain meaning. Now, I want you to take this page. I've got 4 lines of information in here. What these are, these 4 lines, these are words that mean in an equation you're going to add. What is the sum of 2 numbers? You're going to add them. 4 plus 5, you're going to add them. 3x and 8. Eventually, you're going to try to add them, but there's steps in the middle. All together, you got a column of numbers. How much is it all together? You're going to add them. Now, I've got these for subtraction, multiplication, division. By the way, this asterisk mean that it could have a dual use. Each could imply division as a unit pricing in the grocery store. Remainder could mean to subtract. What is the remainder of these 2 numbers? Okay, how much is left over? You see remainder, you think leftovers. Okay, so, yeah, I told you they're not going to be done. What I want you to do before tomorrow night, and I don't care what resources you use. You can use the e-text. You can use Google. You can use Alexa, Siri. I don't care. A thesaurus. I want you to come up with at least 11 under each column by tomorrow. Now, I need to warn you, there is no one absolute set. And I'm disappointed if some student doesn't come up with one that I haven't had in the past. I'm going to have a simple set that I'll show you tomorrow night. But anyway, that's one thing that I want you to do for tomorrow, because it's very important that you understand the language of math. So you will know what they want out of you. Okay? Now, this one, I want you to get it out right now. Well, no, actually, I'm going to do this one tomorrow night. I'm going to take a short detour here. I've got to get out of my PowerPoint so I can do this. Okay. By the way, you're supposed to be scared. That's a storm coming. This one, I want you to get it out right now. Well, no, actually, I'm going to do this one tomorrow night. I'm going to take a short detour here. I've got to get out of my PowerPoint so I can do this.
My story concerns a strange event that took place in a little town nestled in the mountains. A little town inhabited only by natural numbers. But whenever the townspeople gathered together, rumors were exchanged, rumors that other numbers lived in the dark woods beyond the mountains. But no one could imagine a number that wasn't a natural number, so no one believed the rumor. At that time, nobody worried about robberies because if, for example, 5 stole something, he would always take 5 of whatever he stole. There was no special reason. That was just how he did things. And 7 would steal 7 things, and 10 would steal 10 things, no more, no fewer. And because of this, the thief could be easily identified. So there weren't any robberies, and no one bothered to lock things up. But one day, there was a robbery. 9, who was the baker, rushed over to the sheriff's office. 763, who was the sheriff, leaned back in his chair and asked 9 what was stolen. Just a little piece of bread. 1 piece of bread, said 763. I can't believe it. 1 is the mayor. He would never steal. No, said 9. Not 1 piece of bread. A little piece of bread. Not 1 piece of bread, but a piece, said 763. What kind of nonsense is that? I'll show you, said 9. Then you'll understand. 763 hurried over to the bakery shop and was amazed at what he saw. Only a part of 1 loaf was missing. He couldn't imagine who could have taken it. 1 would have taken 1 whole loaf. 2 would have taken 2 whole loaves, but none of the numbers would take less than 1 whole loaf. All right. If no number could take it, then no number did take it. But someone did take it. Someone or something. That night, 763 and 9 hid in the back of the bakery and waited. Suddenly, a little creature in a black cloak crept in through the door and scurried over to one of the cakes. It cut the cake into 3 equal pieces and took 2 and scurried out, leaving the 3rd piece behind. 763 and 9 ran after the strange creature. 763 caught it by the cloak and pulled it off. 763 and 9 stepped back in horror when they saw what was beneath the cloak. It looked like a miniature 2 on top and a miniature 3 on the bottom. It's horrible! Shrieked 9. Then before they knew what happened, the creature ran off. After it! After a long and hopeless chase, they thought they saw the creature run into an old barn on the edge of town. But neither of them wanted to go inside while it was dark. So they decided to wait until morning. at daybreak, 9 went back to town to get help. By that afternoon, a large crowd had gathered in front of the barn, and suddenly the barn door began to open, and a strange creature emerged. But it wasn't the same one that 9 and 763 had seen the night before. It looked like a miniature 4 on top and a miniature 6 on the bottom. I'm sorry if I disturbed anything, it said. I live in the dark woods beyond the mountains. I wanted to see what was on this side of the range. What about that other thing? Asked 9. What thing? Asked the strange creature. It had a 2 on top and a 3 on the bottom, and it stole my bread and cake. Oh, that's 2/3. I didn't know he was here too. He's a real scoundrel. Are there many others like you in the woods? Yes, of course there are. What do they look like? Well, said the creature, there's 1/2. He has, as you say, a 1 on top and a 2 on the bottom. And 5/4 has a 5 on top and a 4 on the bottom, and I'm called 4/6. Is there, asked 5, a creature in the woods with a 5 on top and a 5 on the bottom too? No, not in the woods, said 4/6. He's right here. Where? Right there. But that's 1, our mare. Oh yes, he could also be called 5/5, said 4/6. If 9 would bring some cakes from the bakery, I'll explain how. Now, this cake is for me. So I would cut it into 6 equal pieces and eat 4 of them. If you gave the cake to that scoundrel 2/3, he'd cut it into 3 equal pieces and eat 2 of them. And 1/2 would cut it into 2 equal pieces and eat 1 of them. 5/4 would need 2 cakes. He'd cut each cake into 4 equal pieces and eat 5 pieces. 4/6 then asked 5 to cut a cake into 5 equal pieces. Then 4/6 said, tell me, 1, how many pieces of that cake would you eat? Why, said 1, I'd eat the whole cake, of course. But how many pieces is that? Well, it's 5 pieces. Exactly, said 4/6. That's 5/5. 5/5 is one of your forms. If you really concentrate, you can change forms so that you'll have a 5 on top and a 5 on the bottom. So 1 concentrated and concentrated, and he became a 5 on the top and a 5 on the bottom. But his wife, 186, was so upset to see her husband in this state that he changed back immediately. You see, said 4/6, you're a rational number, just like me, and like all the numbers who live in the dark woods beyond the mountains. But what's a rational number? Asked 1. Well, any number that can change itself so that it has a natural number on top and a natural number on the bottom is a rational number, explained 4/6. Can I do that too? Asked 5. Certainly, said 4/6. All natural numbers are also rational numbers. Pick a bottom number. I'll choose 3. All right, said 4/6. You eat 5 cakes. So we'll let 3 cut each cake into 3 equal parts. Now, how many pieces will you eat? Let's see, said 5. I'll eat 3, 6, 9, 12, 15. 15 pieces. So, one of your forms is 15/3, said 4/6. Because when you cut each cake into 3 equal pieces, you eat 15 pieces. And it was true. For with that, 5 changed into 15/3. But 3, his girlfriend, fainted, so he changed right back again. Well, said 4/6, the sun's going down and I must be on my way. Goodbye, fellow rational numbers. Just a moment, said 763. Where is 2/3? He's wanted for burglary. I don't know. Since we're all rational numbers, I'm no more responsible for him than you are. That's right, said one. Have a safe journey, 4/6, and remember, you're always welcome to return. Afterwards, 9 discovered he could become 18/2, and one said, I'm 2/2, and 3/3, 4/4, 5/5. Wait a minute, cried 763. All of us can have many different forms. That's right, said the others. Then, said 763, pointing to the mountains, they can have different forms too. Of course, agreed the others. Then, said 763, 4/6 can take other forms also. What do you mean? I just have a hunch, said 763. Look at this piece of cake. If we cut it into 6 equal parts, our friend 4/6 would eat 4 of them. That's right, agreed 9. So, we'll put 4 pieces on this tray. Now, asked 763, how much would 2/3 eat? Well, 9 said, he'd cut it into 3 pieces and interrupted 763, eat 2 of them. But that's what 4/6 would eat, shouted 9. Exactly. Then, said 9, 4/6 is the same as 2/3, finished 763. I'm going after him. Maybe I can still catch the scoundrel. Throughout the years, many of the rational numbers from the woods came into the town to join the natural numbers, until the time came when all of them lived there. Even 2/3 came, and 763 continued to chase him. But 2/3 always found a new form to escape from 763. Many years later, rumors came that strange new creatures were now living in the dark woods beyond the mountains. The rumors said that these creatures were numbers too, but they couldn't take the form of a natural number on top and a natural number on the bottom. It was said that some of these numbers were rational numbers, but some weren't. But no one could imagine what a number would be like that couldn't take the form of a natural number over a natural number. So, no one paid any attention to the rumor.
I need to speak very briefly about some other stuff that was in that movie that are in your homework. They expect you to know the different number sets, like the set of whole numbers. That's numbers countable by fingers and toes. Now, the difference in whole numbers and natural numbers is 0 is not included in the natural numbers. Okay? The next set of numbers beyond that is the set of integers, which this did not address. The positive and negative counting numbers and 0. Then the next set in the building system is the set of rational numbers, which is what this was about. And rationals can be positive or negative. And I think the illustration of how rational numbers work may be worthwhile for some of you. Okay, then those strange numbers beyond the mountains. There are still 2 sets left. One of them is a set of irrational numbers, numbers which can't be expressed as a fraction. Well, actually, they can with some manipulation. It gives you a repeating decimal. Okay, and some of them are in decimal form. And then you've got the imaginary numbers, which we will be hitting very hard this semester. Okay, so that's the number structure system, which is an objective for this course. That being said, I want to just show you this. This is something that I did in 2003, as you can see. And next to the last, I was a presenter at the National Middle School Conference in New Orleans, which is an whole nother story of fun. But anyway, this was part of my presentation, just an excerpt of the hour-long presentation I did about things to help algebra students to be successful. Okay, things that you might assume that people would know. Assume meaning an algebra teacher might assume this, but maybe they do, maybe they don't. And some of these are pretty important. So we're just going to look at this very briefly. This is about how you identify numbers and a little bit about what you can combine to make like terms. Anybody ever heard that phrase before? Like terms? It's kind of a different approach to discussing like terms. I never was a proponent of the old apples and oranges are different, you can't add them. That never made sense to me, so I came up with my own way of identifying. So anyway, here we go. Variables rule in any equation. I call it blending. Okay? Now, what is blending like? It's like oil and water. I'm not sure why those are all pressed together. First, before I talk about oil and water, I want to go over some assumptions and general statements of how we do stuff. Some of this might or might not be worth taking a note of. Okay, now, anytime you have a variable or parentheses, there is a hidden one in front of it. Anytime you've got a variable, an X, there's a hidden one if there's no other number there. If you have a parentheses, if there's no number in front of it, there's a hidden one. Okay, anytime a number and a variable are next to each other, it means multiply. 7x means you take 7 times whatever x is. And you may not know for a while. Anytime a number and parentheses are next to each other, it also means to multiply. Anytime a term has no sign, there is a hidden positive sign. Now, what about blending or like terms or common terms? I call it blending. It's like mixing oil with water, or oil and oil, which are viscous fluids. Any of you take chemistry know what that word means? Viscous means that they will blend together and make one substance. Okay? That is to say, if you have any kind of x's, multiples of x, that could be 2x, 3x, 2/3 x, or just simply 1x, you can blend that with other plain x's terms. 2x plus 3x is 5x. Okay, you add the numbers, and the x depicts what kind of things they are. Y's, same idea. You know, we use different variables. What if we had xy's? xy, remember I said earlier, anytime two variables are next to each other, that means multiply. So that means that xy means at some point in the future, we're going to need to multiply x times y or divide something to get rid of one. Okay? Now, we can have 3xy plus 5xy and end up with 8xy. Okay? What about powers? You cannot blend or make into one value x squared and x cubed. They are just x squared plus x cubed. Okay? By the way, I just used a word that you could put in your add list. Blend. Okay, so anyway, you know, they've got to be to the exact same power before they can be combined into one singular term. Plain numbers, we call them real numbers. You can always add, subtract, multiply, divide them. You can do anything with that. Okay? That's like mixing water with water. And here's a simple illustration. I have this equation. X plus 3 plus 2x plus 4 equals something. This isn't an equation. It is a expression. Equations have stuff on both sides of the equal sign. Expressions only have it on one side. You simplify expressions, you solve equations. That's some math terminology. So if you read instructions, if it says solve, then that tells you you've got an equation with stuff on both sides of the equal sign. If it says simplify, it's just asking you to combine like terms and that kind of stuff. So anyway, we look at this thing. We want to blend these plain numbers. That's like taking a bottle of green colored water and a bottle of red colored water and add them and getting a bottle of brown colored water. Okay, pretty simple idea. Okay, well, what about the variables? I've already changed, whoops, hit the wrong button. I told you I might do that. I've already changed the 3 and the 4 into the 7. So now what do I do with these? They are like terms, same exact variable component. So I can combine them like a bottle of 1 ounce of oil with a bottle with 2 ounces of oil makes a bottle with 3 ounces of oil. Simple. Now, what if we want to try to combine, okay, there's our 3x. What if we want to try to combine that 3 ounces of oil and that 7 ounces of water? It won't mix. They're not the same kind of things. Okay? You cannot combine those two in their present form to get anything. So what is the answer of this? It's just 3x plus 7. That's as far as you can go. Or as my hillbilly cousin would say, that's as far as you can go. Okay? The idea, have an idea, does the concept of blending oil and water make the idea of what you can combine for like terms, hopefully a little plainer, a little simpler? Okay. And here's just a summary rule. Okay, you can blend like variables, you can blend real numbers until all you got left is the oil and water, which you can't blend. Okay, and that was just my lesson plan associated with that. Okay, you've got this handout.
31.
31. Okay, page 31.
Yeah, 31.
Thank you. Okay. Now, we're going to use some of those things that I told you already tonight, including some of the clue word things. So you may discover some clue words in this process. Okay? If you had a word problem that had that expression in it. Now, let me tell you about word problems to start with. Any English majors in here? No? Huh. I hope all of you took at least 3 or 4 years of English in high school. Now, what do you have to have a sentence? You got to have a subject and a verb and maybe or maybe not an object, right? Yeah. Jack, the subject, went, the verb, to town, the prepositional phrase. There's a math teacher who knows a little bit of English. How scary is that? Well, actually, I was certified to teach English, but I never put it on any of my stuff with the school district because I didn't want to. Likewise, I was certified to teach physics, and I didn't want to teach that either. And 2 or 3 other classes. So, at any rate, how do you do this? If you're dealing with equations, now these are all expressions, half equations, just one side of the equation. Okay. When you're dealing with the equations in word problems, hint, to understand where the equal sign is, so you can write the equation and solve the problem, look for the verb. The verb will always be the equal sign. And then on one side of the equation, you're going to have an expression that might look something like one of these. And then on the other side of the equation, you're going to have another expression. Okay? An extremely simple example of this would just be simply 3x plus 5 equals, I'm going to make up a number 10. And this may not be a pretty number for the answer. Okay? The sum of 5 and 3 times x is 10. Might be a word problem for this. The sum of 5 and 3 times, or the product of 3 and x, is that. See how equation structure is built? Okay. If you understand this structure, then word problems aren't the nightmare that they always possibly have been for you. Okay? Because in word problems, you usually have 2 or 3 sentences. 2 of the sentences describe something about the numbers and the variables. The third sentence usually tells you what it wants you to do with them. Find the total miles. Oh, I got to add something. You know, find whatever. So that's the general structure of math word problems. Now, given that information, and I can't find my pointer, let's go through these very quickly. 5 more than W. You see I have 5 plus W here because however much W is, you're going to add 5 to it. Make sense? Hopefully. Now, there's something we call precedence, or the usual way we do things. When we write expressions like this, even though it's simplified, or translated, if you please, that's not in the usual way we write it. We usually write it in an order of variable first, then numbers. And if we have powers, we put the highest power to the next power to the next power to the lowest power of the variable, and then the numbers. It's kind of the way we usually do things. Okay? So, what would I ideally say the answer to this is? W plus 5. Now, what about this one? 3 more than M. 3 plus M, everybody. Okay? 6 more than N. Okay? The sum of Y and 4. Plus 4. the sum of n and what? 5. N plus 5. That's a 3. 3 times b. 3b. Now, I digress. And I do that often. Let's see. I need the other light on. Thank you. Thank you. I'm going to use the number 3 and the number b because it's in this example. There are better and best ways of writing just simply a multiple, which 3 times b is a multiple. Okay? 3b, just plain 3b, meaning 3 times b, is the absolute best way. It's the simplest form. Now, you could write 3 parentheses b. Nothing wrong with that. You could write b parentheses 3 or parentheses 3 parentheses b. Those are all right, but less good than this because they're not in the simplest form. Okay? It's kind of like that 4/6 hiding is 2/3. Well, what about some others? What about B3? That's a vitamin. Got you there, didn't I? That was one of my better ones. They were quite a groan. Don't do it this way. Why? Because it might be confused with BQ. Okay? So that's why you don't want to do this. Unless you use some parentheses or something like that. Okay? Well, enough of that. Let's go on. 6 times n, 6n. Uh-oh, now we're getting fancy. I gave you a hint on this one a few minutes ago. Right there. Okay, I heard somebody say 2 plus 3p. Okay? That's not wrong, but it's not convention, the normal way. Okay? Remember I talked about variables before plain numbers? So we would rewrite this as 3p plus 2. Now, is that one wrong? Am I going to take off points? No. Do I want you to do it that way? No. Okay, this one's very similar to the previous one. 6n plus 1. 1/2 of n. Of was one of your primary clue words. What was it? What kind of a word was of? Multiplication. You take half of something, you're going to multiply it times a half. Actually, you can divide it by 2 as well. But the word of means times, mathematically. You see it in a word problem, that's a strong clue for you. So, what can we do for an answer on this one? Well, the simplest one is this, 1/2 n. And make sure that that n is kind of there, because technically it's on the same level with the numerator. Now, an equally good answer for this one would be n over 2. It goes to multiply by half or divide by 2 that I just mentioned a minute ago. These are equally good answers. Now you see why I've got the screen halfway up. Okay, 2/3 of n. That scoundrel is sneaking in here. Okay,
3 and 5.
well, that's one of the answers. He suggested 3n divided by 2. Is that what you said?
I think that's wrong, but
I agree with you.
it's 2n divided by 3.
Yes, absolutely. 2n divided by 3, or simply 2/3 n. That's supposed to be an n. Okay? Either of these two is equally good. Four less than n. Now, let me give you a warning. Subtractions are sneaky. They're treacherous. They will mess you up, especially something called a minus in the middle of a little bit in the future. Okay? You really got to beware anytime you see those minus words, because order matters. On subtraction and division, order matters. Addition and multiplication, it doesn't matter. Okay? By the way, that's called the commutative property. Now, are we taking the 4 away from the n, or are we taking the n away from the 4? I hear both. 4 less than whatever n is. So in this case, it would be n minus 4, and only n minus 4. Okay. What about this one? Am I taking the 5 away from the d, or am I taking the d away from the 5? I'm taking the 5 away from the d. Okay, what about this one? C divided by 5, C over 5 is a very good answer for this one, or 1/5 C. Equally good answers. 5 subtracted from n. Okay, you sure about that? Yeah. N subtracted from 15. Nope. 15 is the one being taken away from. Okay. Over here, 5 more than 2 times n. 2n plus 5. Yes, 2n plus 5 would be the best answer. Number 17, 5 less than 2 times n. 2n minus 5. 3 times the sum of 2 and n. Now, they got that helper up there, but I wouldn't write it like that. 3 times the sum. Okay, see what I'm reading? 3 times the sum of 2. I could either put the 2 here and the n there, or ideally I could put the n and the 2. It doesn't matter. Okay. Six times the sum of 6 and k. Well, this one that's a whole lot like this one, isn't it? Very similar to this one. 6 goes out here. Okay. Oh, wait a minute. Where is it? 2 goes out here. And then we have 6 and k, or k and 6. Okay, 10 times n. 10n. Okay. No. There used to be, I gotta do it. I gotta do it. Get ready to grow. This is really bad. There used to be a singing group called Captain in 10. Captain in 10. 10 M. 24 times M, just 24 M. 5 more than twice D. Well, you could have 2 plus, 5 plus 2D, but the preferred would be 2D plus 5. 8 more than H. H plus 8. The square of 3. 3 to the second power. The square of n. N to the second power, or n squared. Okay, you know why they call second power squared? Is there anyone? I'll tell it anyway. In geometry, how do you find the area of the square? Length times width, and they're both the same. Okay, so that's why they call 2 to the second power is squared, because you take, to get square inches, you take length times length, which are the same. Okay, what about if I had this one? The cube of x. So that would be x cubed. Why, do you know why they call cubed to the third power? Same idea as with the square, except 3-dimensional. Length times width times thickness. Okay. Well, what about this one? The cube of two and no, I don't want to write that. The product of 2 and n. The product of 2 and n means I've got to multiply 2 and n together. So here is 2n. And now I'm going to cube that whole thing. Okay. Now, this is important. You cannot write this. That's wrong for this sentence. It is wrong. Because in this case, the cube only applies to the n. Okay. The parentheses means that this becomes 2 cubed n cubed. Okay, very important concept. Okay. So a little bit on writing the expressions, a little bit on the language of mathematics, a little bit on finding like terms, a little bit on finding how to deal with fractions, common denominators, and the like. And so that's where we're going to wrap up tonight. Have a good evening, and we'll see you tomorrow.
I have one quick
Bring this packet to every class. Oh, what? Those put right here on top of this manila envelope. That's your attendance for tonight.
As far as this thing that you want us to do, do you want us to bring it in, or do you want it, or did you want it scanned?
No, just write it on there. We're going to discuss it in class. We're not going to take a grade on it.
Okay.
No, I'm in no rush.
Okay, for my online class, we're going to end now, and I'll record again tomorrow night.